This is the planet Mercury, the closest planet to the Sun and the start of our journey through the solar system, taking a look at what we know about the planets, moons, asteroids and comets along the way. Mercury is the closest planet to the Sun, orbiting at an average distance of around 36 million miles, or almost 58 million kilometres. This means that one full year on Mercury is only 88 Earth days long. Just as a note of convenience, from this point on in the video, I will be using metric measurements and placing the relevant conversions to imperial and scientific units on screen. As well as being the closest planet to the Sun, Mercury is also the smallest planet in the solar system, measuring only 4,879 kilometres in diameter. For comparison, the Earth is approximately 12,800 kilometres in diameter, and the Earth's moon is almost 3,500 kilometres in diameter. Mercury has no moons, and no atmosphere to speak of. Being so close to the Sun naturally leads to high temperatures, and surface temperatures can reach a maximum of over 420 degrees Celsius. On screen we've got some of the other equivalent temperatures in Celsius Fahrenheit and the scientific notation of Kelvin. This temperature is actually hot enough to melt the metal lead simply from being on the surface. On the night side, however, the temperature can plummet to almost minus 200 degrees Celsius, so we've got a really big temperature range. This extreme temperature range is entirely due to the lack of atmosphere. Not having an atmosphere allows all of the heat from the Sun to radiate away into space and gives us the large temperature range we see. Mercury is in a form of tidally locked orbit known as a 3:2 resonant orbit. Basically, what this means is that for every orbit of the Sun, Mercury only completes half a turn on its axis. That's rather confusing, so let's put some numbers to that. One whole year on Mercury takes 88 days. But one full day and night, so sunrise to sunrise, takes 176 days, or 2 full orbits of the Sun. Resonant orbits like this tend to occur when orbits are short and close to large gravity sources. As you have seen from the pictures so far, Mercury has a relatively smooth and flat surface, interrupted by many large deep craters as shown in the shades of blue and violet in some images, which represents their depth below the average ground level. The composition of Mercury is also quite unusual. Mercury has surprisingly strong gravity for its size. The surface gravity of Mercury is around 0.38 Gs. What this means is that you would weigh just over 1/3 of your weight on Earth. In case you didn't know, the G measuring system uses the gravity we all live in as a standard measurement and classes it as 1 G. This allows for easy comparison with other bodies in the solar system. This relatively strong gravity, almost the same as found on Mars, is due to the internal structure of the planet. Scientists believe that a relatively large metal core dominates the inner structure and would once have been surrounded by far more material that was lost in a catastrophic impact many millions of years ago. What was left behind was the Mercury we see today. The first record of Mercury's existence can be found in ancient Babylonian tablets which contain information and observations of astronomy from around 1400 BC. That's nearly 3,500 years ago. The observations were probably made by an ancient Assyrian astronomer somewhere in modern-day Iraq. You might be wondering about the name, Mercury. Well, Mercury was the Roman messenger to the gods. In those ancient times, little was known about the exact nature of the planets, other than they moved differently to the stars visible in the night sky. The word planet actually comes from the Greek term planan and means wanderer or wandering star. It was not just the Romans, however, many ancient cultures associated these wandering stars with their gods. Being the closest planet to the Sun actually makes Mercury quite difficult to get to. A rocket will use a lot of energy getting into the inner solar system. Add to that the relatively uninteresting nature of Mercury when observed from afar, and the reasons for the small number of robotic missions becomes clear. There were simply more interesting things to see in the solar system that were easier to get to. In spite of the difficulty, Mercury has actually been visited by 2 probes so far. the first being Mariner 10 from the United States of America. This probe was part of a larger series of exploration probes named Mariner and flew by Mercury 3 times between March 1974 and March 1975. It returned the first close-up images, some of which are on screen now. You can see a moon-like landscape featuring large numbers of impact craters. Mercury would have to wait 34 more years for another visitor from Earth. This time, the year is 2008, and the probe, also launched by NASA, is named Messenger. Messenger initially flew by Mercury and later entered orbit. During the course of its mission, it produced many high-quality photographs of the surface and was able to completely map it. Most interestingly of all, however, was the discovery of frozen water ice in the deep polar craters. But how can water exist on a planet that reaches temperatures over 400 degrees? The answer is simple. The craters are permanently in darkness. The sun never rises high enough in the sky at the polar regions, and with no atmosphere to transfer the heat, the bottom of the craters remain in shadow and well below 0 degrees. There is currently one more mission comprising 2 satellites en route to Mercury, the joint European and Japanese space agency mission named Bepi-Colombo. The 2 satellites are the Mercury Planetary Orbiter, provided by the European Space Agency, and the Mercury Magnetospheric Orbiter, named MIO, provided by the Japanese Aerospace Exploration Agency. The 2 satellites launched as part of the mission will investigate further the internal structure of Mercury, as well as the magnetic field. The mission was launched in October 2018 aboard a European Ariane 5 rocket and will arrive in its final destination, the orbit of Mercury, in 2025. Due to the complexities of getting to Mercury, the mission will do a number of flybys of both Venus and Mercury in order to properly get into final orbit of Mercury. You may be curious about the name Bepi-Colombo. He was an Italian scientist who worked on the Mariner 10 mission. His work focused on calculating planetary flybys, whereby probes slingshot around a different planet to alter their course towards their target. Mariner 10 was one of the first probes to use these manoeuvres, and this latest probe pays tribute to Bepi and the work that he did. That's about all in our overview of Mercury. Join me next time to see what we know about Venus. If you liked the video, please give it a like, and if you're interested in more of this type of video, think about subscribing. If you've got any comments, questions, or things you think I missed, pop them down in the comments below, and hopefully I'll see you in the next video.